Okay, so we're ready to move on now to continuity. So that kind of finishes our talk on limits, and now we want to talk about continuity here for just a second. Okay, well, you might recall, like way in the beginning of pre-cal, you defined continuity as, not being able to pick up your pencil if you are drawing the function. So if a function can be drawn without picking up your pencil, it has no breaks, no holes, no asymptotes, then we consider that function to be continuous. And when you're starting off in math, then that's a fine definition. But when we get to calculus, we have a very important definition now that we know about limits. So this is the definition of continuity that you'll want to definitely have memorized. Okay, so it says a function f is continuous at a point x equals to c if the following three conditions are all satisfied. The first thing is that f of c is defined. So what that means is that there is no hole. Now you don't want to memorize it as no hole. You want to memorize it as f of c being defined. Because eventually what you're going to need to be able to do is prove that a function is continuous. And it's not enough to just say that there's no hole. You actually have to show that f of c is defined. Okay, the second thing is that the limit as x approaches c of f of x exists. And I'll talk more about that here in just a second. And then the third is that the limit as x approaches c of f of x has to equal to f of c. Okay, so if you want to think about it like this, basically one is saying that the function value exists. So the function value is defined or exists. The second condition is saying that the limit exists. And like I said, I'll talk a little bit more about when a limit exists here in a second. And then the third thing is basically just saying that the first two things are equal to one another. So just to keep it simple, we could say that they are equal. And when I say they, I mean the first and the second thing that you said existed. Okay, so if just one of these conditions fails, then the function is not continuous as illustrated in the three graphs below. So if you look at this first picture right here, f of c is not defined. We see that there's a hole here, and so because of that, the function is not continuous. What you should notice here in the first illustration is that the limit as x approaches c of f of x does exist, okay, because the function is approaching the same y value from both sides. Okay, so the limit exists, but because the function value does not exist, we say that the function is not continuous. Okay, in the second illustration here, which is in the middle, the limit as x approaches c of f of x does not exist. And the reason for that is because the limit as x approaches c from the left, which I denote with a little minus sign above the c of f of x, is equal to whatever y value that is right there. So this is the limit as x approaches c from the left. The limit as x approaches c from the right is down here. So this is the limit, whatever that y value is. That's the limit as x approaches c from the right, which I denote with a plus sign, of f of x. And because those two one-sided limits are not equal, we say that the two-sided limit does not exist. And I'll explain that a little bit lower in the notes when we get to the definition. Okay, in the third illustration here, what if we have both of the two things that we need existent, but they don't equal each other? Well, that's what this illustration looks like in number 3 here. Notice that the limit as x approaches c, the two-sided limit of f of x exists, and that's because the function is approaching the same y value from both sides. Okay. Notice also that f of c exists and is defined, and it's right here. Okay, but because those two things are not equal, we say that this function is not continuous. Okay, so we need all three things in order for a function to be continuous. F of c has to be defined, meaning there cannot be a hole. The limit as x approaches c of f of x has to exist, meaning that the function must be coming together at the same y value from both sides of c, and the limit has to equal the function value. Okay, so that's the definition of continuity. Now, on the AP exam, you're often asked to prove that a piecewise function is continuous, and so that's where I kind of go into more of a definition of when does a two-sided limit exist. A two-sided limit is going to exist whenever the two one-sided limits, one of them from the left side of C and the other one from the right side of C, are equal. Okay, so what that means is that in order to prove the second condition in our definition above, we need to show that the limit from the left side of C and the limit from the right side of C are equal.